Hello, good morning, my dear Abhyasians. The last class we have learned observation of variation of friction with applied force, and in this present class we are going to learn factors affecting friction. The frictional force is affected by what factors we are going to learn right now. So, in the affecting factors, so does the roughness of the surface affects the friction or not? We are going to see factors affecting friction. So the roughness, that is activity number 3, and the area of contact. So area of contact, does the frictional force depends upon area of contact, and does the frictional force depends upon normal force or not? We are going to see. So for this activity number 3 has given, for this activity number 4 as given in the textbook, and for this activity number 5 given in the textbook. So it is independent of, frictional force is independent of area of contact. It depends on roughness of the surface in contact. It depends upon normal force or normal reaction force. Now we can see the third activity, that is effect of roughness on friction. We can see effect of roughness on a frictional force. We can see now. For this one, set up an inclined plane on a horizontal floor. So this is our horizontal floor and this is our inclined plane. Set up an inclined plane on a horizontal floor as shown in the diagram. Use a wooden board. This is called wooden board. Wooden board as an inclined plane. So I am using this wooden board as an inclined plane. Now put a mark at any point on this wooden board. So I am taking the mark here, that is called A. Put a mark A at any point on this wooden board. Now let a pencil shell or a ball drop from that point. So leave from this point A. What do we observe, my dear students? We found that the ball starts rolling, picking up its speed, and from here so from here its speed decreases and finally it stops. So because as the ball is rolling from the bottom of the inclined plane to here, the frictional force is opposing its motion. Friction will act in this direction, we know. It will act in this direction, opposite to the motion of this ball or pencil shell. So fine. So the friction is stopping that. Now identify the distance traveled by the ball from the bottom of the inclined plane to the point where it comes to rest. Here, from here to here, it has traveled. So distance covered I have noted. Okay, students. Now what do I will do, my dear students? So now spread a cloth over this horizontal floor. Now I am spreading a cloth over this horizontal floor and see that there should not be any wrinkles on the cloth. Again leave the ball on this surface. So again leave the ball on this surface. So observe the distance covered. Is the distance covered same in both the experiments? No. In which case it travels minimum distance, in which case it travels maximum distance, we have to notice. Okay students, and we get the result that why does it covers different distances when moving on different surfaces. And we know that only the frictional force is stopping when it is rolling from here to here or somewhere. Okay, only frictional force is stopping, that you know, and that friction is different when different surfaces are in contact. We can repeat the same experiment by keeping a marble tile, or you can keep here a glass also, and observe the distances covered and identify the distances traveled. So distances are different, you are getting, means friction force offered also different. That's why smoothness or roughness of the surfaces. So the smoothness, or another name of that is what, children? Roughness of the surfaces of both the floor and pencil cell could affect the distance travelled by each. Okay, that is only means the smoothness or roughness of the surface of both the floor and the pencil cell, or you can call wall, okay, affect the distance travelled by it. Means that when different surfaces are in contact while it is rolling, so first time horizontal floor and the ball, second time cloth and the ball, third time tie and the ball. So different surfaces, different kinetic frictions offered, so different distances it travelled or covered before it comes to rest. So we can conclude that, so the surface of the, we can conclude that the smoothness or roughness of the surfaces of both the floor and the pencil could affect the distance travelled by each. Okay students, then, and how does this friction arises? What is the cause for the friction? We are going to learn now. Cause of friction. So cause of friction on different surfaces we are going to see. Now see my dear students, this is one body and that is kept on a horizontal floor. This is an object kept on a horizontal floor, and those two surfaces are in contact. These two surfaces are in contact. Don't get confused that it is just a circle. It is just telling that the horizontal surface and bottom surface of the block are in contact. They are in contact. And though many surfaces look like a perfect planes for our naked eye, the surfaces appears, this surface appears very smooth, or this surface appears very smooth to our naked eye. But when we see the surfaces through a powerful microscope or a strong microscope, there exist many ups and downs on the surfaces. So there exist many ups and downs. Those ups and downs are called irregularities. My dear students, remember this irregularities word very clearly. So ups and downs. See the top surface and the bottom surface. Bottom surface of the horizontal floor will be like this when we see through a powerful microscope, and the top surface of the object will be like this, and these irregularities of the two surfaces are interlocked with each other, and because of that irregularities, friction is caused by irregularities on the two surfaces which are in contact. So friction, cause of friction means irregularities, my dear students. Irregularities are nothing but ups and downs on the surfaces. These irregularities are ups and downs interlocked with each other. They are interlocked, locked each other. So locked into each other or interlocked. See this up and the bottom surface up and the top surface down. They will be interlocked like this. There are some interlocking. So they have interlocked one another like this. So when we attempt to move any object on the surface, for example, if I try to move this block on this horizontal surface, we have to overcome the interlocking. So how do we overcome the interlocking? We should apply some force to overcome the interlocking. So we have to apply some force to overcome those interlocking. Then the motion just begins. Okay, students. So that's why force of friction is greater if rough surfaces is involved. The frictional force will be more when the rough surfaces are involved. Rough surfaces means interlocking will be more. So we should apply large amount of force to overcome that interlocking. Okay, students. So that is the cause of friction and effect of roughness. So or smoothness. Roughness increases, frictional force increases. Okay, students, next activity we can see, does the frictional force depends on area of contact or not, that is independent. We can see that experiment also. Okay, students, in activity number 3 we have learned factors affecting the frictional force, that is the roughness. So we know the result. If the roughness increases, frictional force also increases. So friction is increases with the rough surfaces. We know that. Now, does the frictional force depends on area of contact or not? So effect of area of contact of frictional force means, does the frictional force depends on area of contact or not? We are going to see in this activity number 4. For this purpose, take a brick. This is a brick, you know. Take a brick and tie the brick with a string and pull the brick by a spring balance as shown in the diagram. So we are pulling this brick by spring balance. So in this direction. So this is called spring balance. This is the device. Spring balance is a device to measure the applied force. Spring balance is a device to measure the applied force, and we know this is our spring balance. Now, in the spring balance, stretch in the spring balance is directly proportional to the applied force, because when we are pulling this spring balance, there will be an elongation in the spring, so that the stretch produced in the spring balance is directly proportional to the applied force. And the change in length of the spring balance, in the spring balance, one spring will be there, that spring gets elongated, gets stretched when you apply the force at this end. So means more stretch will be produced and more amount of force is applied on the spring balance to pull this brick. Okay, so the scale on the spring balance gives the reading of the scale, means up to what point or what limit it has extended. The scale on the spring balance gives the reading of the applied force by you on this handle of the spring balance. Okay, students. Now, we are pulling this brick, and note down the reading of the spring balance when the brick just begins to move. So when the brick just begins to move, note down the reading of the spring balance at that instant. So see the number of forces acting on this brick when it is just begin to move in the horizontal direction. Horizontal forces on the brick I want to find when it is ready to move. So one is the applied force on the brick and another one is the frictional force. In this direction we have frictional force and the spring balance is pulling this brick. So this direction we have what we know students, applied force. So means here F is the applied force. F means applied force. If that applied force is equal to the frictional force, here, then the brick just began to move, and note the reading of that applied force, that is called the maximum limit of the frictional force at that instant. So we are noting the maximum frictional force offered by the surface when it is just began to move, and we are measuring its reading in the spring balance. Okay, students. So now turn the brick as shown in the diagram. So turn the brick that is upright as shown in the diagram and pull the spring balance. Means repeat the same experiment in this situation also, and note down the maximum limit of frictional force. So we are taking maximum limit of frictional force, maximum limit of frictional force when the block just began to move. So frictional force, the instant when the brick just began to move, when the brick just began to move. When we turn the brick upright, the area of contact of the brick with the surface is small. and here the area of contact of the brick with the surface is more. But in both the situations, when the brick just began to move, we are noting the frictional force. So that is, we are noting the frictional force, which is indirectly is equal to we are noting the maximum static frictional force when it is just began to move, and this can be obtained by the reading by the scale of the spring balance, that is called F applied force. We are noting down, we get the same value. So we are getting the same maximum frictional force to pull the brick in both the cases, even though the surface areas of contact with the surface are less. Means we can, from this experiment, we can conclude that conclusion. So conclusion, we can conclude that frictional force is independent of the frictional force is independent of area of contact. So area of contact with the surface. So frictional force is independent of area of contact with the surface. So frictional force is independent of area of contact. That is this activity. So when we are pulling the brick, it is in horizontal position. When it is in horizontal position, and when it is in vertical position, pulling the same brick with another orientation and pulling the brick with horizontal orientation. In both the situations, the applied force is equal to the maximum limit of the frictional force, and that we are getting same. It is independent of area of contact. So the next activity we can see, does the frictional force depends upon normal force or not? Okay students, in the activity 4 we have seen that frictional force is independent of area of contact, and also in activity 3 we have discussed that frictional force depends on the roughness of the surface. The frictional force is greater if more rough surfaces are involved. Now, effect of normal force on friction. So means frictional force depends on normal force or not. I want to see normal force is due to the letter N. Okay children, affecting factors of friction means in the textbook he mentioned 3 things for us. One is roughness, second one is area of contact, third one is normal force. And we already have learned these 2 activities. Now, does the friction depends on normal force or not? We are going to see the third one, that is activity number 5 in our textbook. So for that You see, children, so now the frictional force depends on normal reaction or not. We are going to see normal force. Normal force or normal reaction also we can call with the letter N. Okay, see students, in activity 3 we kept a block horizontally on the floor and we pulled this with a spring balance and we measured the maximum applied force required to pull this block. Just it is ready to move. At that situation we have the maximum static frictional force. It is called maximum limiting friction. Here F max name is, so maximum limiting friction, its name is maximum limiting frictional force or friction. Maximum limiting friction force required to pull this block we calculated with the help of this spring balance. In that situation, this F maximum is equal to the F we learned. Okay, and we know how to calculate also. That we will get the reading of the spring balance here. We have seen in the activity number 3. So when one block is there, this is only one brick. Its mass is m. So it will be attracted by the earth. You know this is a mass kept on a horizontal floor. Okay, students. Now every object is attracted by the earth, we know. So that's why this object is attracted by the earth with some gravitational force that is called weight W acting downward direction. So because it is attracted by earth in the downward direction, but still it is not moving down, means the floor is counterbalancing its force. That's called normal force. It is called normal force or normal reaction. So this force is perpendicular to the surfaces in contact. This is the surface of the block and this is the horizontal surface. So this is the normal force N and this is the weight W. Okay, when this block just ready to move, in that situation we are noticing the value of the applied force here. If that is exactly equal to F maximum, it is ready to move. In that situation we calculate the maximum limiting frictional force. We know from the previous discussed activity, when we increase this applied force, frictional force also increases. This is called friction force or frictional force. It is called maximum friction. It is also increases. When means these two surfaces are interlocked. The top surface and the bottom surface, these two are interlocked with each other. Those two surfaces are interlocked with each other. When there is no applied force, no frictional force. My dear students, remember that we already know that static friction is a self-adjusting force. It adjusted by itself only. If you try to push a Beerwa or a washing machine in your home like this, it is not moving. Let us consider you are just pushing and it is not moving. Means someone is counterbalancing that force. Someone is counterbalancing your applied force. That force comes because of the interlocking of the floor and the bottom surface of the washing machine. They are interlocked with each other like this. They are interlocked. When means you are increasing, so you are just pushing. Slowly you are pushing, it is not moving. You are increasing the force, it does not move. Let us consider. Means as your applied force increases, frictional force also increases in opposite direction. But you know that there is a limit to this frictional force. It can develop up to particular value only, and beyond that it cannot increase. If our applied force is more than that, it is ready to move. So means if our applied force is 0, frictional force is 0. Applied force is 10 newtons, frictional force may be 10. Applied force is 20, object is not moving, frictional force also 20. If applied force is 50 newtons and the body which one you are pushing is not moving, so then frictional force also 50 newtons. Means this friction can develop up to particular value only. So when our applied force is just sufficient to break the interlockings, or it is sufficient to overcome the interlockings, then it is ready to move. So the friction has encountered in that situation. So fine, here also these two surfaces are interlocked, you know my dear students. So I am pulling, when it is ready to move, means this interlocking, we are able to overcome this interlocking exactly with our applied force. Means our applied force is exactly equal to the maximum static frictional force. Because it is at rest, this force we call it as static, and it is arising due to friction. It is friction means it is due to the interlocking of irregularities, you know that. So that's why, so the maximum limiting frictional force we calculated in this situation. Now put one more brick on this brick. So that is, I added one more brick, and again I am pulling, and again I am pulling with the help of the spring balance. So see here children, we have this brick mass is M and this brick mass is M. Total 2 bricks, total weight is, so only one brick weight is mg. 2 bricks will be attracted by the R. So the total weight is 2 mg. Means now the total normal reaction is different from the first situation. It will be different here, it will be more, and here also we will get the frictional force, applied force we find it will be doubled. So here the applied force required to pull this block, if it is 50 newtons, here we will get that applied force is 100 newtons just to move this arrangement. Means if we add a brick to the existing brick, if we add a brick, I added, see children, this is brick 1 and this is brick 2. If we add a brick to the existing brick, or you just push this brick down, push it down with your finger, you push it down and try to see the maximum applied force to move it, it will changes. Because when you are pushing down, in addition to this weight, some other force is adding, so normal reaction will be increased. If we are unable to push it, just you add one more identical brick. So first brick and identical brick, another brick I added. Okay students, now I want to pull this arrangement just to bring it into motion. So now in this situation I will have the maximum static frictional force this side. This is called maximum limiting frictional force. We will calculate. That will be doubled here. doubled here. Means we can say that when normal force is doubled, we know it is in vertical equilibrium. Vertical equilibrium means here N is equal to mg. Mg means this mass, its weight is acting downward direction, normal reaction acting upward direction. There is no vertical motion means, so we know that we can write here N is equal to mg here, and two bricks are there which are attracted to the earth in the downward direction. So since they are not moving means floor is exerting an equal magnitude of force in the vertical upward direction. This is called normal force, we know that, and it is in vertical equilibrium means net force must be 0, means N dash must be equal to this weight. So here the normal reaction is, so now we will get the normal reaction. Normal reaction N dash is equal to 2 mg we will get. Means when normal force increases, frictional force also increases. That is called the maximum limiting frictional force to pull that block also increases. So that's why we should remember an important relation, that is frictional force. The maximum limiting frictional force is directly proportional to the normal force. This maximum frictional force, if I know the letter F, maximum frictional force with the letter F, so maximum limiting frictional force is directly proportional to normal force. And this is called proportionality symbol. This symbol representing, this symbol is representing proportional to, means when this normal reaction increases, it says that, it means that when normal reaction increases, this maximum frictional force also increases. So normal reaction increases, maximum limiting frictional force also increases. So that is the affecting factor of normal reaction on frictional forces. Means if you put one more block over it, if you keep one more, what students, keep one more wooden block, keep one more wooden block, so keep one more wooden block over it. So again the frictional force, the normal reaction will be doubled now, because 3 mg is acting downward direction. So normal reaction will be different. Again the frictional force, to pull one block we need 50 newtons. To just pull 2 blocks we need 100 newtons. To just pull 3 blocks we need, so 150 newtons. So at the situation here the friction is trying to oppose and this is applied force. These both are balanced. It is just begins to move. It is ready to move. In that situation, the frictional force is called applied force. This applied force reading will get the reading of the spring balance. Spring balance scale reading is the applied force. That is what maximum static frictional force. The limit of maximum static frictional force is directly proportional to the normal force. That will represent like this. So the factors affecting friction are how many students? 3. One is roughness. So more is the roughness, more is the frictional force. Smooth is the surface, frictional force is less. And frictional force is independent of area of contact. It doesn't depend on area, how much area is being in contact with the surface. Okay, it depends only on the normal force. And frictional force is directly proportional to normal force.